Struggling to understand strings in Rust? Stay with me, because you are not alone. The pattern of learning a new programming language is always the same. First, you read something about its syntax. Maybe you try your first Hello World example, and you think you have grasped the main features. Sooner or later, you want to test your knowledge, and string manipulation are always a fun way to do it. Maybe because, as humans, we think in terms of symbols and words, or maybe because under the hood, strings are more complex than what they seem to be. While other languages take convenient shortcuts, Rust takes a unique, more efficient approach. Welcome to the world of string and string references, where simplicity meets power. Stay with me till the end of the video, because today we are unlocking the secrets of Rust strings. First, let's break down the difference. Both string and string references are used to handle strings, but they serve distinct purposes. String is like a trusty sidekick. It's owned, mutable, and ready to grow as needed. This UTF-8 encoded string type is perfect for when you want to modify your string's contents. On the other hand, a string reference is more like borrowing a cup of sugar from a neighbor. It's a string slice offering a view into a string or a string literal, meaning a sequence of characters which is coded as binary text directly into the compiled code. Unlike string, a string reference is borrowed, meaning that it doesn't own the data. It's immutable, so you can't make changes directly to it. Think of string as the main course and string reference as the appetizer, offering a sneak peek without taking ownership. Understanding this difference sets the foundation for efficient and effective string handling in Rust. In the world of Rust, string and string reference handle ownership and mutability differently, okay? Which can significantly impact how you work with strings in your code. Why does this matter? It matters because this has to do with ownership and mutability. Understanding ownership and mutability is crucial for memory safety and preventing bugs like data races. Strings are owners, meaning they have exclusive control over the data they hold. This means that you can modify the string freely, but you are responsible for managing its memory. On the other hand, a string reference is more about borrowing and using data without taking ownership. This distinction becomes particularly important when passing strings between functions or dealing with concurrency. So, for example, imagine you have a string containing a message. You can pass this string around, modify it, and even transfer ownership to other parts of your code. However, if you try to pass a string reference into a function that expects a string, Rust will complain, because it wants to ensure that a borrowed reference doesn't outlive the original data. This is where understanding ownership and lifetimes becomes crucial in Rust programming. Another critical aspect of understanding string and string references is, of course, memory management. Let's explore how memory is handled for each type. When you create a string in Rust, Rust allocates memory on the heap to store the string's contents. This allocation is dynamic, meaning that the size of the string can change at runtime. For example, when you append more characters to a string using the method pushString, Rust reallocates memory as needed to accommodate the new content. This dynamic memory allocation is powerful, but it comes with responsibilities. You, as the programmer, are in charge of managing this memory. When a string goes out of scope or it's explicitly dropped, Rust automatically deallocates the memory it was using. This automatic memory management, thanks to Rust's ownership system, helps preventing memory leaks and ensures memory safety. On the other hand, a string reference does not require its memory allocation. Instead, it's just a borrowed reference to an existing string or a static string literal. This means that it does not have ownership of the data that it refers to. It's more like a pointer and a length pointing to a section of memory. Since a string reference is borrowed, it does not need to worry about memory deallocation. Its lifetime is tied to the data it borrows. When the original string is dropped, any string reference becomes invalid. This ensures that dangling reference, which are a common source of bugs in other languages, are prevented. Why does this matter? Understanding the memory management differences between string and string references is crucial for writing efficient and safe Rust code, guys. So, if you need a string that can grow or shrink dynamically, string is your choice, but be mindful of managing its memory. On the other hand, if you just want to work with a string without taking ownership or worrying about memory deallocation, then a string reference is your way to go.
Understanding how string and string references behave as function parameters and return types is crucial for designing clean and efficient code. Let's explore how these types interact in function signatures. When defining a function that takes a string as a parameter, you are essentially transferring ownership of the string to the function. This means that the function now has full control over the string, allowing it to modify or consume the string. So, for example, the capitalize function here takes ownership of the input string. It capitalizes it and then returns a new string with the modifications. The caller can then continue to work with the return string without affecting the original. So in the main scope we create a new string s using the string from method. So s will be lowercase string. And then we call the capitalize method on s and we assign the result to another variable called s uppercase. So now if you try to print to the standard output the previous variable s, this program will not compile because it will produce an error at compile time. And this is because the value of s has been moved out from the main scope into the function capitalize. On the other hand, if a function takes a string reference as a parameter, it borrows the reference to the string. This means that the function can use the string's data, but it cannot modify it. The borrowed string reference maintains its immutability within the function. Here, the countWords function takes a borrowed string reference, it splits it into words, counts them, and returns the count. The original string reference remains unchanged, and no ownership transfer occurs. The choice between string and string reference as function parameters depends on whether the function needs ownership to modify or consume, or only needs to borrow the string. So, in the main function now we define s as a string literal, and now we call the countWords function on it. Differently from the previous example, now if you try to print to the standard output this variable s, now the program will compile, because we are not moving out any ownership. When a function returns a string, it is transferring ownership of the string back to the caller. This allows the caller to take ownership of the return string and continue to work with it. So now we define this function creates string, which just creates a string with a string from method and then moves out the string s from the function scope back into the main scope. On the other hand, if a function returns a string reference, it's like lending a reference to a portion of a string or a string literal. The function does not transfer ownership, but rather allows the caller to borrow a view of the returned data. So, in summary, choosing between string and string references for function parameters and return types depends on whether ownership is needed and whether modifications are required. Rust's ownership system ensures that string handling is efficient and safe, preventing unexpected side effects.
So, today we've unlocked the secrets of strings and string references in Rust. Now, let's recap the key points. String is owned, mutable, and dynamically allocated, perfect for when you need to modify your string. String reference is a borrowed view into a string or a static string literal, immutable and efficient for borrowing without ownership. Understanding ownership and mutability is crucial for memory safety and efficient code. So, as you dive deeper into Rust programming, remember to Choose string for ownership and mutability. Opt for string reference when borrowing a view without ownership. Practice using both in your Rust project to solidify your understanding. So guys, that's it for today. I hope you've enjoyed the video, and with these new tools in your belt, you are now well equipped to tackle the world of strings in Rust. Happy coding!